Good morning, guys. So we're going to do composite functions and inverse functions, and we're going to do examples from these different sections. So for one, find f3 if fx equals negative 4x squared plus 5x. So x, your new x is 3. You're going to plug 3 into here. So when you do that, you get f of 3 equals negative 4, 3 squared plus 5, 3. And you get negative 36 plus 15, which is negative 21. Okay, and then for 2, f of 3x, so 3x is your new x, so you're going to plug it into here. You're going to get 4 minus 2, 3x squared. And this is your answer. Okay, oops. And then for 3, find the domain of this function. So for this, we can factor it out to get this, and we know the bottom can't equal 0. So this x cannot be 5, and this cannot be negative 5. So our solution set would be x cannot equal 5, and x cannot equal negative 5. And this x is our variable representing our domain. And if you wanted to write it in interval notation, it would be written like this. So x cannot equal negative 5, x cannot equal 5. Next section, we're given this table. So f of g times 1 is also f of g 1. So this is your x, so you're going to look at the x, and you're going to find 1, and you're going to go down to g and find 0. So you go to 0 and our x again, like right? So then now you go down to f, and you get negative 1. So first one is negative 1, and that's one where it's asking f of g. So this is also f of g. So let's skip to c. So you have g of f, negative 1. Right, so you find negative 1 in the x row, go down to f, find this new number, and then go down to g. You get 8. Okay, and then g of g, negative 2. So g of g, negative 2. Find negative t, go down to g. Find your new x, go into g. It's also 8. So that's g of g. Let's do f of f. So this is f of f, negative 1. And so you start here, go down to f, go down to f, and you get negative 7. The second table is the same idea, so we're going to go down to this section. So let's do A, g of f, negative 1. So we're given two graphs. We're given y equals g of x, and then y equals f of x. So for A, we look here, it's f on the inside. So we're going to look at this graph. And so when x is negative 1, you see x is negative 1, y is 1. So now we're going to look at this graph. When x is 1, here, y is 4. So our answer is 4. So that's an example for g of f. So let's do an f of g example. So let's do d. So f of g, 4, is, so we're going to look this time at our g graph. See, so we're going to look at this one. And so you have 4 when x is 4. When x is 4, y is 2. So f of 2. Now we're going to look at this graph. When x is 2, y is negative 2. So that's your answer. Okay. So for the next section, for each one we have to find f of g, g of f, f of f, and g of g. So for number 11, for the first one we have f of g, 4. So when we look at g here, we're going to look at this g and plug our new x into here. So you get f, 3, 4 squared plus 1. That equals 49, right? So this is our new x. We're going to plug it back into here. Because it's here, so we left it on the outside. So we're going to plug this into here. And so it's going to be like this, and our answer is 98. Okay, so we're going to have to do that for everything else. So let's do g of f, which is g of f 2. And so you're going to look at f, so here, and you're just going to plug it in here, this x into here. So you get g 2, 2. And that gives you 4, right? So this gives you 4. Now you have to plug it into here, because g is on the outside, so you gotta plug it into here. So you get 3. 4 is your new x, so like that, and then you get 49, and then you have to do that for everything else. Yeah. Okay, and then let's go to another section. Okay, let's go to 29. So for these ones, you have to find the domain. So you have to do f of g, g of f, f of f, and g of g. So let's start with f of g, x, which is also f of x. So look at g, and plug it in. So, and then now plug it into here, that equation. This is your new x. So see how this is that? Yeah. And your answer comes out to be 6x plus 3. So your solution is all real numbers. And when you do it for g of f, f of f, and g of g, it all comes out to be all real numbers. But 35 doesn't, so we're going to do 35. So let's see, f, we start with the first one here. So f of g, x is, let's see, so you look at g, put that in. Okay, and then you look at, it's your f, so you're going to look at that. And you're going to plug it in also, so let's see, plug in your new x, trying to find the, what do you call it? The least common denominator. Okay, so here x is on the bottom, so you know x cannot equal 0. But we're going to keep going in case something else comes out. So right now I'm multiplying by the reciprocal. And you're going to get, okay, so x cannot equal 2. So when you write the solution set, it's going to look like this. X cannot equal 2, x cannot equal to 0. So that's for A. For number 35. So for number 35, A, the thing is x cannot equal 0, x cannot equal 2. Okay, so now you have to do B. Okay, so see g of f of x. Look at your f. Put that in. Okay, so here you see that x is there. So x cannot equal 1. And you can keep solving, but it won't tell you anything. So you just know that x does not equal 1. So for your solution set, 4b is the domain of x cannot equal 1. I have to do C, f of f. So f of f, x, look at f here. You're going to plug it in, 3 over. So here you also see x cannot equal 1, right? Okay. But we're going to keep going, so, because we got to plug it. You got to plug it in again. See, so you're putting this this x into this thing. So it's going to look kind of long. Okay, so it's going to be like this. Least common denominator again. Oh no, okay. Okay, so we have that multiplied in. Okay. Okay, so this is 3 times x minus 1 over 3 minus x plus 1. Which gives you 3x minus 1 over 4. Okay, so here you see x can not equal 4. So x cannot equal 4, x cannot equal 1 for C. So for C, x cannot equal, why is it, okay, x cannot equal 1 and x cannot equal 4. And then for D, which what is it? Oh, G over G. G of G. So G of Gx. G2 over x, right? Because you have this. Now you're going to plug this back into this because it's G of G. So it's kind of like you're working backwards. So multiply by the reciprocal. Okay, but here you know that the bottom is x and x cannot equal 0. So for D, x cannot equal 0. Yeah, and that's how you do that. So now let's do this section. So we need to show that this is equal to this, which is equal to x. Which means it would either simplify, it would basically kind of simplify to 1. So let's do 45. So we're going to do f of g, right? So f of g. Okay, let me write it like this. F of g, which is also f of gx. So you see your g, so you're plugging this in as your x. Now this new x, you're going to plug into here. So, well, so this would mean it would be 2, right? Because you're plugging, was this half? Yeah, you're going to plug this into here. So yeah, because this cancels out, so you're left with x. So it's true. Should we do another one? Okay, let's do another one. So 47. Here's 47. You have, let's do f of g, x. See, you have f of 3 rad x. So so this g is this. See, because I looked at g. And now your f, you're going to have to plug it. Take this, plug it into there. Okay. So, when you plug it in, it's literally gonna cancel out. So it cancels out, so you're just left with x, so that's also true. Lastly, let's do 60. So for 60, if f of x equals x plus 1 over x minus 1, find f of x. So f of x, you're going to plug it in, x plus 1, x minus 1, right? Because this is this. So you're going to plug it in. But now you still have this on the outside, and you have to find this. So you're going to replug your new x into your little x's. So it's going to look like this, right? Because you're plugging it in. Okay, so I'm going to multiply both the top and bottom by their denominator to get the least common denominator. Okay, and then when it simplifies, it's going to simplify. Okay, so you're going to get okay, so this is what you get, and it's going to simplify to 2x over x minus 1 over 2 I can't talk, 2 over x minus 1. And here, x minus 1, so you know x cannot equal 1. Okay, so we're going to move this. Okay. We're going to continue from here to see if it leads us to anything else. So you have 2x, x minus 1 multiplied by the reciprocal, and everything cancels, so we have this, so our solution set is x cannot equal 1. And that's it.